So, good day students, and welcome to the homework session on biochemical processes to make biofuels from biomass. But before we go into that, I will want to remind you what a fuel is. A fuel as such, aside from nuclear fuel, is a combustible substance. A biofuel is a fuel that is produced from a clean, non-contaminated biomass. Firewood is a biofuel, and charcoal is a biofuel. Olive oil is a biofuel. Dry pieces of fish or bacon is a biofuel, and so on. The sludge found in wastewater treatment plants is not a fuel. It's not combustible. Neither is wet pulp from, say, lemonade production. So in most cases will biomass not have to be converted at all to become a fuel, but in some instances may a conversion be necessary. Provided the biomass has no strong cell walls, and if it is wet on top of that, then are the biochemical conversion routes the main alternative. So the overall aims of this nugget are first to give you a basic knowledge about the two main biochemical conversion processes. And these are ethanol fermentation and anaerobic digestion. So the products are ethanol and biogas. Both products can then be post-processed and further upgraded depending on the end-user demands. And in your homework you will have a look at that. You shall also gain a first insight to which are the demands on the feedstock. You may have heard about lignocellulosic ethanol. So what is the problem with that? We will also talk a little about the side products and residues. Everything that has to do with bioenergy aims at a sustainable system solution. So householding with natural resources and circular economy and closed loops are absolutely crucial. And that includes how the side products can be used. And that, in turn, demands quality of the side products. And then you must also gain an insight to the process demands. Because if you do not understand what the process demands, then you will not be able to judge if it is feasible. Finally, you shall apply this knowledge and try to find what might be the local market for biochemical conversion in your home region. What about the feedstock? What about the demand for the fuels? But first, you must learn some of the basics about the processes. I cannot know if you remember anything about the material you used and read in the second nugget in the previous lesson. In that nugget, dealing with cell walls and membranes, did you use an online biology textbook? I selected that book because the descriptions of cell walls and membranes was very good. If you want to, then feel free to use that textbook again. But for this nugget, you would want to go to chapter 7. That chapter deals with cell respiration and metabolism. But there is another online biology textbook that I think fits better when it comes to describe the process of alcohol fermentation. Before you went on with this homework session, did you look at what the rest chains material had to say about fermentable sludge? So you will remember that one glucose molecule plus yeast fungi would give rise to 2 ethanol molecules, 2 carbon dioxide, and ATP. This is of course a very rough summary of a complex process. And you shall not learn the details of the process, because that would be to go too far. But I will want you to know just a little bit more. So in this slide is a copy from the Estrella Mountain textbook. This figure shows the glucose consumption as it occurs in the yeast fungi if there is no oxygen available. What you will notice in this slide is that there are 2 intermediate compounds produced. What the yeast does is to extract the energy from the glucose molecule and store that energy in adenosine triphosphate, or ATP. And as you remember from the first lesson, is ATP one major energy carrier in the cell. The result is the conjugate base to pyruvic acid. This compound, pyruvate, may be used in the cell, but in ethanol fermentation is each stripped by one carbon dioxide, and then two acetaldehydes are formed. Acetaldehyde is soluble in water, but is also carcinogenic. So inside the yeast will there be a potentially carcinogenic substance. Now, there's no reason to panic for this, because the yeast will normally use up all the acetaldehyde to produce ethanol. But this is an example to illustrate why you must know a little more about the processes you are using. You should be aware that the complex processes you are using do involve substances that may involve health hazards and must be treated with due respect. Now, glucose is not the only type of a sugar. Glucose is a hexose. That is a type of sugar that has 6 carbon atoms in the molecule. But many sugars are pentoses. They have 5 carbon atoms, and they cannot be digested by the most common type of yeast, namely Saccharomyces cerevisiae. This is the main reason why ethanol fermentation is so limited. The feedstock must contain mainly hexose sugars, and such feedstock is also suitable for human food and for livestock. So, as it is today, is the main part of the world's ethanol production based on corn and on sugarcane. So there is a competition between the production of ethanol for fuel and the production of food. And this is obviously not sustainable. Therefore, there is ongoing research to find ways to produce ethanol from lignocellulose. But as of today, 2020, has this not yet been successful. Or that is to say that the processes are not commercial. One way to promote ethanol production from lignocellulose is to combine it with other products. In the link list to this nugget, you will find a paper by González Calderón and Arantes. And I would advise you to download and scan that paper so as to get an idea of the problems and the options for ethanol fermentation. But now let us have a look at the second main process. Anaerobic digestion is a multi-stage process in which a multitude of different microorganisms successively degrade carbohydrates, fats and proteins into acetic acid, and then finally use the acetic acid to produce methane gas. The text you read in the Discipline Handbook, and especially in chapter 4.3, will have given you a first insight to some of the important factors for a successful process. But there is one source on the web that is very useful, and that is the Biogas Handbook. The handbook is a commercial product, but you do not have to buy it. 3 of the chapters in the handbook are free to download. These are chapter 4, which is a simplified introduction to the biochemical processes that occur. And then chapter 18, which deals with substrates. And chapter 35, which will introduce you to the basics of reactor design. On top of these 3 chapters, you should also download Appendix 16, which is a glossary. These texts, together with the Discipline Handbook, will give you the knowledge required for this course. And then, one more thing. Go to the website of the World Bioenergy Association and download the latest global statistics. There are 2 versions, a high-resolution one if you want to use their graphics, and a low resolution which is good enough for reading. And what you shall read in that report is chapter 1, which is to introduce you to the global energy system. And then read chapter 5. That is about biomass conversion to liquid biofuel. The previous nugget dealt with 2 such fuels, FAME and HVO. And in this nugget we have talked about ethanol. So Chapter 5 will give you an overview of the global situation for these three. Then read section 6.1, which is about biogas. Nugget number 2 in this lesson dealt with physical conversion processes, like pelletizing. And section 6.2 in the statistics deals with pellets. The next nugget will deal with thermochemical conversion processes. Section 6.3 in the statistics report deals with one of these products, namely charcoal. And then read Chapter 7. In the previous nugget, you looked around in your own region to try to find industries that might use FAME or HVO for fuel oil replacement. Now, ethanol is not a very good fuel, not even when it is purified, but it can be used in some processes. The raw biogas is not a very good fuel either. Once purified to biomethane, it can be used much the same way as fossil gas. So, just like in the previous nuggets, I now want you to concentrate on your own home region. You already did an estimate of the possibilities to produce pellets in the region. And you have considered which industries in the region might replace the use of fossil-based light fuel oil by liquid biofuel. So what I want you to do now is to try to find how much fermentable biomass residues are available in the region. That would be like cassava, bagasse, residual molasses, or fruit biomass, or alike. You should exclude wheat, corn, maize, and everything else that can be readily used for food or fodder. Only residual products that have no main use shall be considered. And remember that biomass for fermentation must be rich in hexose sugars. And then do the same thing for digestible residual resources. Try to quantify the amounts, and also think about potential customers and end users. And then challenge yourself, thinking about the residues. Can the residues from fermentation be used for cattle food in your region? Can it be used as a fertilizer? How much can be used? How much can be produced? And what about the digestate? Will it be free from heavy metals? Will it be free from pathogens? Will there be traces of medicine in it? How will you guarantee the quality of the residues? Again, you should make notes of your findings because you will need these things later.